with this presentation, we will then answer questions. Okay, and I still see people coming in, so please bear with us for another minute or so before we begin. Excellent. So again, welcome everybody, and over to Marco for the presentation.
Good afternoon. Welcome to the webinar on application security with OAuth and Keycloak. And before we start, I would like to take some time and talk about who we are, who Console is. When you're going to look us up, you will see that we have we are situated on 6 locations, 2 here in Germany, 1 in Munich, 1 in Düsseldorf. Düsseldorf is the location where I'm normally situated. Furthermore, we have 1 location in Krakow, Poland, 1 in Vienna, Austria, Dubai, and 1 in San Francisco. And what do? We have 4 main parts that we are active in. The one is IT consulting. So when you have questions or need expertise, you can call us. We provide IT solutions ready to use out of the box, for example, Control CM. Also, you can modify this solution to your needs. The third thing is software engineering. So if you have an idea for a software product you want to have, you can talk with us. And also we provide IT operations. That's one of the factors why we are distributed all over the world. So we can guarantee 24/7 support for you, our customers. So who am I? My name is Marco Bungert. I studied bioinformatics and computer science in Jena. And from 2013 to 2018, I made my PhD in Kassel, and since 2018, I'm a software engineer at Console. If you want to talk with me and you see the handle Turing85 together with this penguin, that's normally me. So if you want to chat, just write me and we can have a chat. My key interests besides Keycloak are also GraalVM and Quarkus. So let's get started with the topic of today, OAuth2 and Keycloak. Let's have a look how things were done in the good old days when we had a monolithic application. Normally, when we wanted to have a server-side login, the login was done really on the server side with authentication and authorization. Normally, this was managed through session state that was held on the server. And when we needed to scale, we normally scaled vertically, not horizontally. So when we needed more RAM to the machine, we added more RAM. When we needed more CPU capability, we added more CPUs, and so on. When we are now talking about scaling in the cloud and moving to the cloud, we have the problem to synchronize a session state among multiple instances and multiple services. This can be done, for example, by introducing a caching cluster, but this adds complexity. And also, depending on your use case, you maybe want to have the features of social login, so login with Google, Facebook, GitHub, you know what. The solution to this problem is straightforward. We just shouldn't take the state and store it on the server, but rather store it on the client side. So, for example, in your application or in your web browser, and hold the state there instead of holding it on the server. This gives us the possibility to scale horizontally instead of vertically. And also we can use the same authentication method amongst multiple services. So what is OAuth2? It's nothing that's provider specific. It's a protocol for authentication authorization. It's standardized. The RC is linked here. And it is the base for OpenID Connect. And OpenID Connect, you can think of as social login, so the login with Google, Facebook, and whatnot. which is also standardized, so you don't log into a specific product or a specific vendor. There are multiple products out there providing login with OAuth2 and OIDC. And with these products, we can achieve a single sign-on principle. So your customer logs in once and can use all the services, all the infrastructure, which leads to a good user experience. Okay, so why should you use OAuth2? Why not another protocol? OAuth2 is somewhat old. It was developed in 2012. It's battle hardened. We have different quote unquote flows for different use cases depending on how good your front end or your client is able to keep a secret. We have the authorization and authentication without server state. So the state is held on the client side, not on the server side. And the backend systems that govern whether a user is allowed to access certain resources or not evaluate tokens that are generated by the authentication unit, by the server, to grant the authorization decision. A short notice here, we won't look at different flows here, and also we won't look at how to implement the backend systems. Implementing the backend systems to use such tokens is the quote unquote easy part. The harder part normally is to get the infrastructure started with your OAuth server and configuring your OAuth server for your needs. Furthermore, by separating the authentication, so who is trying to get access, from the authorization, so what is the person trying to access, and is the person allowed to access the resource, we have a separation of concerns, which is always good. Also, since OAuth2 is a standard and relatively old, we have good client library support. So if you want to use OAuth in your, for example, a TypeScript front end, there are libraries developed for this. If you want to use OAuth in your Java backend, there are libraries for this. Or if you want to use it in Python, there are libraries for this. You don't have to write the code yourself. So what's the general flow of an OAuth system? Normally you have a business client, which is, for example, your front end, and the client requests access through to log in by the OAuth server by, for example, sending a password, or you get a little pop-up. You may know this when you link your accounts to Google, you get a little Google pop-up. You enter your credentials, and in return, the OAuth server verifies for one the client, so who is accessing the service, and verifies the user credentials. And in return, if both checks are valid, returns a token, and the token contains all information necessary to authenticate the user. With this token, the business client can then access the resource server, for example, a server holding images or documents, and authenticates as the user logged in the first step. The resource server then can decide, does the user have the right privileges to access the resources, and if so, return the resources. In this step, that's what's shown under step 6 and 7, some communication with the OAuth server may be necessary. So in general, the business client talks to the OAuth server to get the token. When the business client has the token, it provides the token to resource servers, and the resource servers makes decisions based on the token and grants or denies access to resources. Okay, so that's a wrong slide. Why should you use Keycloak? There are a multiple of services out there providing OAuth2 and OIDC capabilities. For example, Auth0, Okta, and Keycloak are just 3 of them. But Keycloak is one of the few verified, open source, and free to use OAuth and OIDC servers. I've linked a full list of all verified servers here, so if you want, you can take a look. It is developed by Red Hat JBoss since 2014, so it's quite a stable product. You have the capability of on-premise hosting. Some commercial tools do not allow on-premise hosting, but are designed as software as a service. And with Keycloak, you have configuration flexibility. Normally, if there's something that is not there that you want to have, Keycloak is pluggable, so you can write your own plugin and extend Keycloak to your needs. Furthermore, Keycloak is cluster and cloud ready, so we can cluster multiple instances to work in conjunction with each other. And Keycloak allows us to use other authentication methods, for example, LDAP, Kerberos, and you name it. Especially here, you have the capability to extend this capability to include more user federation or other protocols that are not included by default. Most of them are already developed as community plugins, and if you have an exotic protocol, there's nothing stopping you from writing your own plugin. Keycloak is in active development, so it's not a product that was developed in 2014 and has stopped development. Quite the opposite. The last major release was done, I think, in late 2019, and the last minor releases were done 3 or 4 weeks ago. So it's a product that's in active development, has a community, has developers behind it. Also, if you need enterprise support for Keycloak, it is available as product from Red Hat in form of Red Hat SSO, so Red Hat single sign-on. Before we get started with the demo, we need a little bit of nomenclature to know what you are talking about. The first thing we need to know is the resource owner. That is the person owning a resource, normally our user. So that's the person that creates an image or a document and grants access to this document. Then we have the authorization server. In this talk, this will be a Keycloak. Authorization here for me is a little bit of a misnomer. The server provides the authentication through tokens. So the server guarantees that I am the person who I say I am, nothing more. The tokens generated by the authorization server are signed. Signing gives the benefit that once they are created, they cannot be changed without corrupting the signature. And they're stored typically, for example, in the front end of your application, not on the server. Then we have the resource server. That's a backend system providing resources, images, documents. And this backend system makes decisions, authorization decisions, based on the token and the information contained within the token. And while making these decisions, it may invoke the authentication server for further information. And finally, we have a client. The client is an entity making requests against Keycloaks. For example, if you write a front end and the front end is making requests against Keycloak, this front end needs a client. Also, if you're writing a backend and the backend needs to communicate with Keycloak, this backend needs a client. They may be all the same, although if they need different information or need different passwords, for example, it's a good idea to separate these clients into distinctive clients, not use one and the same. Before we get started on the tutorial, a little word of advice. You can use OAuth2, for example, provide authentication and authorization to your cluster, for example, your Kubernetes cluster. You should not, in this case, you should not deploy the OAuth provider within your cluster. Reasoning is if something within your cluster goes haywire, the OAuth service might be affected and you have locked yourself out of your system and cannot fix it. Another way around, which is done, for example, by OpenShift, is that you deploy the service within the cluster, but in dedicated nodes, for example, the infrastructure nodes. So if something in your production cluster goes haywire, the infrastructure nodes are not affected and you have still access to your cluster and can fix the problem. Okay, so let's get started and let's see, hope that the demo guys are with us. For our demo, I prepared a little Docker image, or 2 Docker images to be exact. I will start up the Docker compose I've created. And while this is starting up, I will show you what this image or this Docker Compose contains. So it's a nothing up my sleeve argument. This is the Docker file that just started. Just let me check that's actually starting. Yes, it's starting. We see that 2 Docker containers are contained within this file. The one is a Postgres service providing the persistence layer for Keycloak. This is not necessarily necessary, but for this talk we can use this to, if we want to restart the Keycloak server, these information are consistently stored in the Postgres pod. And down here we have the configuration for the actual Keycloak Docker container. We see here that we are configuring the database connection. We are telling Keycloak to run on port 8080. We create an initial user with name Keycloak and password Keycloak, which we are going to use in a minute to log into Keycloak. And finally, we tell Keycloak we tell Docker to remap the port 8080 to the local port 8090. So let's take a look on our deployment. You should see when the Docker container is started that this is the last line in the log file. Keycloak 10.02 started in 26,000 milliseconds. So when we go into one of our browsers, this one here, and access localhost, and we take port 8090, remember this is the port we mapped to, we are greeted by this site, and we want to access the administration console. Here we use the login defined in the Docker file, so Keycloak. Oh, maybe when I type the password right, Keycloak lets me in, and this is the administrative console of Keycloak. There are a few things to notice right here. In the upper left corner, you see master. Master is a realm, and in Keycloak, you use different realms when you want to separate your users. So if you have a group of users where you know, okay, I have a common set of rules, common set of mappings, we will see what it is in a minute, they all belong to one realm. So if we need other rules, other mappings, other clients, we can create another realm. And master realm is always a default realm created by Keycloak. It's used to manage Keycloak itself. So when we take a look into the users tab down here, don't be confused. You will always see an empty page right here. You have to click the view all users to get the users loaded. And by sure, here we have our user Keycloak, which you just used to log in. So you should not use this master realm to deploy your business case users. Instead of this, we should create a new realm. Let's call it app-realm and click create. So we have separated the part of Keycloak that Keycloak itself needs to run without problems from the actual business case users we want to create. And the first thing we are going to create right here is our clients. Without clients, we cannot make requests against Keycloaks. We see already here that some clients have been created by Keycloak itself. We will not go into detail what these clients do. Rather, we will create 2 new clients, one client called service 1. Save. For this tutorial, we want to enable this client. We want to provide confidential access since we are going to use the direct access grant. Normally, this is not used in production, but for demonstration purposes, this is the easiest flow to use, and we will not use standard flow. So we have configured the first client, and we are going to save the client. When we are saving, we get a new tab right here, the credentials tab, and Keycloak has generated a secret for us. We need this secret for some point later, so we will store it right here. And now we are going to create a second client. Let's call it service 2. Configure it the same way. We want it to have confidential access, and we do not want to use the standard flow enabled. Here you can see the credentials tab is not yet here. Just when you're going to save, the credentials tab will be generated for us. And again, we copy the secret and store it for later use. That's not the correct secret. We need this secret. So now that we are set up to make requests against Keycloak, we need some users to make requests. For this, we go down here into the users tab. And just to show you, there are new users here. I can click here and there are new users. So let's create a new user. Let's call her Alice. We want to enable Alice. Email is not relevant for right now. So we have created the user, but we haven't yet set a password. If you don't set the password and try to make request for this user, you may run into some problems. So let me show you how this might look. We are going to use the tool Postman to make our request. And the first thing I want to show you is the URL we are going to use. So you see up here, okay, we are accessing localhost port 8090, auth realms, and here's the realm we have created, app-realm. So if we, for example, want to make requests against master, we would use master here, but we are going to use app-realm. Protocol OpenIT connect. And since we want to generate a login token, the last part is /token. For the body, we want a grant type of password. In the web UI a minute ago, this was the direct access grant. We want to make the request as service 1. The secret we have stored right here. So we are going to copy this secret over, like so. Like so, like that. And we provide the username and the password for the user we want to log in. When we are now going to make this request, we see we get an for one unauthorized, and the message tells us invalid user credentials with. So the user was not fully initialized. So when we go over to Keycloak and set our password to, let's say, password, and set this password and try to make a request, we are going to see the message is different, but we get a 400 back. The message here is saying our account is not fully set up. This is the case because I did not toggle this switch right here. The password I've set was only temporary, so we cannot log in with this password. This password is only used for the user to initially log in and set his or her password. So let's make it permanent by providing it as password, and toggle the switch right here. And let's make a request again. And sure enough, now we get a status of 200 OK. And we see in the body some information. The two relevant parts are, for one, the access token right here and the refresh token, and the other information are meta information. For example, this access token right here is valid for 5 minutes. The refresh token is valid for half an hour. Token type is BERA, so if we want to use this in a header to authenticate, we would send an authentication BERA header, and the rest is irrelevant for this part right now. The refresh token can be used in case the access token expires, but the refresh token is still valid. So in this case, a refresh token can be exchanged against a new access token and then possibly a new refresh token. This is what you normally know as remember me, or when you go to your Chrome browser and Chrome still knows who you are. Somewhere in the system, in the cookies, one refresh token is stored that does not expire, and every time you go to Google and you're not logged in, the browser or the web application will use this token to generate a new access token. So as I said before, the access token stores all information necessary to authenticate this user. Looking at the string right here is relatively complicated for us since it's base64 encoded, but there's a neat website out there called jwt.io, and you can paste the token right here, and it will decrypt the token for you. Remember, it's only a base64 decryption, so it's not a security decryption just for transmitting it. It's simpler to transmit it in base64. Here we can see that the token itself is divided into 3 parts. These 3 parts are separated by dots. First dot is some header information, which algorithm was used to sign the token, which key was used to sign the token, and what is the token format. In this case, it's a JWT token, so a JSON web token. The second, the largest part, is the actual payload. We'll take a look at this in a minute. And the third part is a signature generated by the payload and by the private key. So when we are looking at the payload, we are looking here on the right side right here. Let me enlarge this for you. We can see some information. So we can see information, some information of the token. For example, when was a token created, when it is going to expire. We see the audience. We'll take a look at this in a minute. The subject right here is an UUID, and when we take a look at the Keycloak user that was created, Alice right here, and take this side by side, the subject right here, this UUID, is the same as Alice has in our server. So that's one possibility to map the token onto the user, but there's another possibility we will see in a second. The second possibility to map is the preferred username down here. Here we can see the clear text name Alice, as it is in our Keycloak server. And the main part of the token relevant for us are those 2 parts right here. One are the realm access roles. These are roles assigned to the user, so roles assigned to Alice. And the second part are roles assigned to the client that made the request, so to service 1. Those are the information normally used by a backend system to decide whether or not a user has access to a certain resource. In particular, this part right here, so the user roles are the ones that are normally used. So looking at this token in total, one could ask the question, okay, why is this here included? Or more specifically, could ask, how do I get rid of this part right here, because my backend system does not need to have this part right here. For this, we are going to take a look at the Keycloak server and the Keycloak client used. This is the service 1 client right here. And in this view, we can take a look at the client scopes assigned to our client. And we have a scope roles right here that's assigned by default through Keycloak to every newly created client. Okay, to see what this scope actually does, you can go into the client scopes, roles, and into the mappers. Mappers define how information from the Keycloak servers are transferred into the token. Right here we have 3 mappers. For one, we can resolve the audience. That's going to generate an entry right here. We can map the realm roles, that are the roles that are assigned to the user. So this part right here. And the third part is mapping the client roles. That is what is generating this part down here. If we do not wish to include the client roles, we can just simply go forward and delete them. Like this, like that. So let's generate a new token. We are going to use the same request we used a minute ago to generate a new token. And we already see that the token is a little bit shorter. We take the token and parse it again. And for sure, the client roles are gone, and we are left alone with the RAM access roles right here. So now remember, we modified one client scope, and client scopes are assigned to clients. So when we take a look at the second client we created, service 2, it has the roles mapping as well. So by modifying the client scope, we modified the behavior of both clients, and to demonstrate you that this is actually the case, we are going to make a request, the same request we did just a minute ago, but instead of using service 1, we are going to use service 2. So you see, everything is identical except for we are using service 2 and service 2's secret. URL and all our other information are the same. We generate a token, and this token, the hyphenations, this token also has the client roles excluded. So the next thing you normally want to use is you want to add your own roles. So you want, for example, a role to upload pictures, or a role that defines that only certain document can be downloaded by a certain user group. For this, we go into the roles section right here, and we see here are 2 roles already predefined. Those 2 rules are Keycloak internal roles, and we want to add our own rules. For sake of demonstration, let's say we need a user role assigned to all users, and we want to create an admin role assigned to all admins. To use those roles, we can now go into our users, into Alice, for example, and say, okay, Alice, you are now a user and an administrator. And now we go back to Postman and generate a new token. And this token will now include our 2 roles, user and administrator. So we added some new roles, and those are normally the roles used by our backend system to make the decision, is this access for this user allowed, or should I reject this access or this request? Now, the next step normally is to get rid of the Keycloak internal rules. So we want this rule and this role and this role to appear, but we do not need these 2 rules right here. For this, we go back to Keycloak. We go into our clients and go into the scopes right here. Normally, this is configured to access all scopes. So everything, all roles mapped are included into the token when this client service 1 is used. We can toggle this one off and say, no, I only want to include admin and user scopes when I make requests with client 1. So when we go back to Postman and generate a new token with client 1 as service 1, we take this token right here and parse it. And for sure, we see that only the roles user and administrator are included. Now, keep in mind that we made this setting on service 1. We didn't make the setting globally. So service 2 right here still has full access scope. This means when we switch back to Postman and make a request as service 2, take this token right here and parse it, roles are still included. So that's the part for the demonstration. And if you have gotten a taste of Keycloak and want to know more, for one, there are 2 great websites, one for OAuth2 and one for OpenID. I've linked you the websites on this slide. Then when you're playing around with OAuth and Keycloak, jwt.io is a great tool to pass your tokens and to take a quick look what is contained within the token. Then there's a great website, great getting started guide for Keycloak. And also in this demonstration, I used the Keycloak Docker image to boot up my Keycloak environment. The image is very well documented, so all settings I've used within the Docker compose file right here are well documented, and you can modify it to your needs. And last but not least, you will find the code I've used, a step-by-step guide, the slides, right here on the GitHub repository, so github.com/console/keycloak-webinar. So let's recap. We have talked about OAuth, OAuth2 as authentication authorization mechanism without server state. We have talked about the standardization of OAuth2, so you're not locked in into a specific component or a specific vendor. And we have seen that OAuth2 is battle hardened since it's quite a while around and has seen some attacks and was hardened and secured this way. We have looked at Keycloak as open source, free to use and verified provider of OAuth2 and OIDC. Keycloak is highly configurable and highly extensible. We have talked a little bit about user federation, so you can use your LDAP or Kerberos users within your Keycloak system and authenticate against Keycloak, against LDAP and or Kerberos. And we have enterprise support for Keycloak with Red Hat SSO. And finally, in the demo, we have seen how clients, users, and roles are used, and we have seen how we can the information stored within Keycloak through MapPass to generate entries within the JWT token created. So I hope you enjoyed the session and thank you for your attention. Are there any questions?
Yeah. Again, thank you, Marco, for now. Everybody, please type your questions into the group chat if you have any. One of the participants said he had hoped to get some infos about application integration. Can you at least give us some pointers about where to look for that stuff?
Of course. So application integration on the backend system, just to clarify? Or
you just said app integration.
Okay, on the backend system, you have integration solutions that are, for example, baked into Spring Boot as well as Java EE. For the front end, you also have libraries. That is what I mentioned at the start of the talk, that you have very, very good client support. Also, you do not need to create your users over the web front end of Keycloak directly. You can remote control Keycloak through a REST API, and there are also good client library supports to remote control Keycloak and, for example, generate users from your website. I hope this answers the question.
Yeah, and if there are any typical pitfalls.
One of my first pitfalls was I used the groups. So when you're looking at the Keycloak web UI, I used the groups as quote unquote roles. So I hadn't the concept of roles yet, and I thought, okay, I group users into groups and the groups are my roles. You can do this, but it's not recommended. Rather, groups are just used to bundle common roles and then assign groups to users. So your the layer of assignment where you decide what a user is allowed to do and what not should always be the role level, never the group level. The group is just to say, okay, these are common roles that belong together, and typically if one user has one of these roles, he or she should have all of them. So assign the user the group with all the roles, not the single roles.
Just to clarify this, so this is different from what, for instance, in an Active Directory, you have as a group where you would say, these are my administrators, and then everybody in that group has that role. So it's kind of the other way around, right?
It's more like an additional level. You say, these are my administrators, or this is my administrator group. For example, I could then here say I want to have an admins group. And instead of adding the admin role to each single user, I just say, okay, I go into role mapping and assign the admin role to this group and maybe also the user role. And now I can assign, for example, I hope I start the group is stored. I can assign the group admin to Alice. And remove the roles right here. But you will see here in the grayed out area, the active roles still include user and admin, since the roles are coming from the group admin.
Okay, so
but
it
you should never use a quote unquote naked group. Groups should always have roles assigned to them.
Okay, excellent, thank you. Another question was if you can tell us a bit more about the integration with an LDAP. So, for instance, you have an existing Active Directory and how you could use it in combination with Keycloak.
Up front, I have never integrated an LDAP directory within Keycloak. The knowledge I have is purely on the theoretical level, but the idea is that you can use the user federation right here. You can set up your LDAP server. So you need to connect both instances. LDAP needs to know Keycloak, Keycloak needs to know LDAP. But then when you make requests, as we did here with Postman, you can not only make requests for the user stored within Keycloak, but also for the user stored in your LDAP system. And you can also pull information in the LDAP from this user. So you can map attributes of the LDAP users back to the token, and so generate JWT tokens for your LDAP users.
Okay, thank you. And the last question here was, and nice, thank you from the person asking this. And another one was whether there is support for multi-factor authentication, which is,
yes,
of course, all the rage these days and very sensible to have.
Yes, there is, let me just look it up where exactly it's stored. I know that somewhere around here, I think it's on the user level. Maybe it's not on the user level. Here it is. So under authentication, you can set up OTP policies, so one-time password policies, and you can also set up multi-factor authentication. For example, here FreeOTP and Google Authenticator are supported. And you can configure your realm so that either all users need to have a one-time password set up, or known users, or the user can decide whether he wants to set up or not. So yes, you have support for multi-factor authentication in the form of OTP authentication.
And I would guess that anything else can, if needed, be implemented by plugins, right?
Exactly. That's a big feature of Keycloak. Everything is pluggable. If there's something not there that you want to have, you can write your own plugin, or look around. Maybe the community already has a plugin for it.
Mm-hmm. Okay. Another question, since you were at the beginning, I guess, talking a bit like login with Facebook, can you integrate that?
Yes, exactly. That's the login with, let me call it login with other stuff, is divided into two parts. The one is user federation. So here you have your Kerberos, LDAP, and whatnot. And the other part is identity providers. Identity providers is OIDC, so that's the protocol sitting on top of OAuth2. And here you can set up, for example, login with GitHub, Facebook, Google, LinkedIn, but you can also set up your custom identity provider. So if you already have an OIDC system that's not listed here, but you want to use it, you can set it up. This is an extension of OAuth2. There are some more mechanics involved, and a little bit more communication. But this allows you, for example, to map, let's say, Google user to a specific user within your Keycloak system, and you do not need to store the password of this user. Since through the identity providers, this password is stored at Google's site. It's a Google password. You do not need a separate password. You just get a special token from Google that says, hey, this user is known on my site as, for example, in my case, marco.bungard@googlemail.com. And somewhere within Keycloak, I know, okay, this user, marco.bungard@googlemail.com, maps on user Marco, and I can create a token for this user. That's the general idea behind OIDC.
Okay, so you could probably also cascade it, like have one Keycloak server just for authenticating the users and others using that as identity provider, right?
Right.
Yeah.
Exactly.
Okay, I think that was the last answer. So if anybody still wants to know something, please type up now. Yeah, I guess that was it.
Great, then thank you for having me. And if you are interested, just hit me up. And if you want to have the slides and the demo code, you can go to, let me type it out for you. Over here, github.com/console. And there should be a project Keycloak webinar. The Docker code I used is included, as well as the slides you've seen, and a step-by-step guide with the things I've shown and a little bit more. So if you're interested, just take a look and let me know if there are any more questions. Thank you.
Thank you, Marco, and thank you everybody for staying with us so long, and have a nice evening.